This is day 11 of Advent of Code 2025, and this challenge is called Reactor. You hear some loud beeping coming from a hatch in the floor of the factory, so you decide to check it out. Inside you find several large electrical conduits and a ladder. Climbing down the ladder, you discover the source of the beeping, a large toroidal reactor which powers the factory above. Some elves here are hurriedly running between the reactor and a nearby server rack, apparently trying to fix something. One of the elves notices you and rushes over. It's a good thing you're here. We just installed a new server rack, but we aren't having any luck getting the reactor to communicate with it. Glance around the room and see a tangle of cables and devices running from the server rack to the reactor. She rushes off, returning a moment later with a list of the devices and their outputs. The puzzle input, which looks like this. Each line gives the name of a device, followed by a list of the devices which its outputs are attached to. So BBB, DDDEE means that devices BBB has two outputs, one leading to D and the other to E. The elves are pretty sure that the issue isn't due to any specific device, but rather that the issue is triggered by data following some specific path through the devices. Data only ever flows from a device through its outputs. It can't flow backwards. After dividing up the work, the elves would like you to focus on the device starting with the one next to you. An elf hastily attaches a label which just says U, and ending with the main output to the reactor, which is the device with the label out. To help the elves figure out which path is causing the issue, they need to find every path from U to out. In this example, these are all the paths from U to out. So from U to B to D to D to G, and then G to out. So from U to B, then to E, then to out, U to C to D to G to out, C, E out, C, F out. So in this one, there are 5 paths. How many different paths that can lead from U to out? Okay, that sounds pretty straightforward. So I assume with this one, start with U, and you're basically just going down every avenue to get to out. There's probably going to be some aspect of once you're at a letter, you probably need to when you find a way out, you probably need to record if that letter gets to out something. Yeah, we'll figure this out as we go. Kind of just thinking about the real input, which will be very large. So let's start with passing the information. This will be a dictionary. Got a graph which connects the server to its outputs. String. This should be a list of strings. I've got the dictionary on there. Okay, so now we go through each line in input, and we want the parts which is split on the colon. Line dot split on colon. So equals, if we split on colon, it'll be like that. So source server will be parts 0, and then what we need to do is let's do var targets is equal to parts 1 dot split on that, and we will get rid of all remove empty entries, then trim entries like that. So we've got our source and we have our targets. Now we'll do for I forgot about source up here. So source this graph source equal to new, then for each var target and targets graph source to add target. Wait, what? Oh, I did string. There we go. So we've created our graph. So so we've got the start of it now. I've built it up. We now need to, let's start with string start is U, string end is out, just so we don't have to type the strings out continuously. So we want to keep record of, for each server node, the ways it can get out. So it's distinct paths. So obviously avoid, like, are there any like loops that could be done? It's like U, B, no B there, let's say C, E. So it doesn't appear to be loops. So I assume that means we can just keep record of the amount of ways that a server can make its way to out. Is that right? So okay, we've got this all sorted out, and let's do our server count. Let's just call it that. To be a new dictionary of string to int, and to prevent a server being going to the same server multiple times, if that is possible, we will create a hash set called visited new hash. Oh, not hash code, hash set. This is a string, and this will be recursive because you need to go down the paths, then record the number of times we get out. You then go back up, you go down another. Okay, +1, +1. So this has to be recursive. So it'll be int. Let's do find paths, and you'll return pass into it the current server. So if we do if current is equal to end, you return 1. Return 1. So once you reach the end, you'll return it, but the recursive place where you're calling find paths, I'm going to add that to the number. Actually, let's go down here and do int total paths is equal to find paths start. So it makes it a bit more obvious how we're doing it than total paths. So we start off here, go call this find paths, pass it start, and it's not. So if it's not at the end, what you want to do is figure out if we've already visited that server before. So so it's possible that, okay, so yes, there should be an if statement. So server count.try get value, and this will be current, and this will be int, let's say cache out int cached. There we go. Then return cached. So if we already know how many possible paths a server can take from that point of a server, it can take to go to the end, we just retrieve that same value back and return it. Because if you get up to that point again, then it's the same amount of times to get to that from that server to the end. So if it's cached, we return. And if we're in a brand new server, oh, actually I forgot about visited. So if if visited contains current. If it contains current, then that means we've done a circular, which is not what we want. And we return 0. So because we're just cancelling it there. And if we get to this point, we want visited to have current. And now we actually start from the current server. We go to all of its outputs. Let's do int total equal to 0. And then we'll do bar connected is equal to graph current. We'll do for each bar connection in connected. Do total plus equals find paths connection. Then return total. Actually, no, before we return total. So basically, for this for each, this current server has done every possible attempt at connection I can make for the current sequence of servers. So we've exhausted every possible in this current sequence. So when it goes back to the calling server, that server's no longer in it, so we need to actually remove it. So visited dot remove current, and then yes, we need to do server count current is equal to total, and then we return it. So I think that's all that needs to be done. Let's try run it and see. Let's try run it and see. We got 5. That is correct. Let's try with the actual input. It's pretty large, but I think we've done a good job of caching that. Won't have an issue. So we'll run that. 552, and that was correct. So let's go on to part 2. Thanks in part to your analysis, the elves have figured out a little bit about the issue. They now know that the problematic data path passes through both DAC, digital to analog converter, and FFT, a device which performs a fast Fourier transform. Still not sure which specific path is the problem, and so they now need you to find every path from SVR, the server rack, to out. However, the paths you find must all have visited both DAC and FFT in any order. Okay, so for example, this new list of devices contains any paths from SVR to out. However, only 2 paths visit both. Okay, interesting. So let's make a start on that. I feel like, let's take a look at SVR in here. Okay, so in the previous one, SVR didn't get visited at all. Now I've got a brand new one. Paste SVR there. So I guess first thing we can do is copy most of this and paste it in part 2. But then we need to change the start from U to SVR. And my initial thought is we'd have 2 booleans for, let's do string DAC is equal to DAC, string FFT is equal to FFT, and bool DAC visited equals false. Maybe we don't actually need to do this. We just need to check if it's visited in there. So this will be a bit interesting. I'm just going to create a boolean here. EAC FFT visited, and this will just be return visited dot contains EAC and visited dot contains FFT. So let's look at this. So let's say if EAC FFT visited, turn 1, otherwise turn 0. Maybe we can do that a couple more times in places. Okay, what are the chances that's the only place that needs to be done? Let's run and see. Okay, the given key U was not present in the dictionary. Did that happen? Line 57. Ah, okay. We will comment out part 1 because it's a completely different test set now. So let's just run that. Okay, returned 0. So actually, I feel like the way I was going to do it doesn't. I think it's not going to properly work. I think better way to do it would be passing it as a parameter in the function. Oh, actually, yeah. Just thinking about this. Doesn't work. Yes, okay. We need to change how we're recording this. We need to record the server location, the server name, and then booleans for if we've visited DAC. What were the other ones we need to visit? DAC and FFT. So that's how we'll do it. So function we pass in has a visited DAC, has a visited FFT. Then based on those values, we can retrieve if from that server location it can actually is at the end. So over here we'll change this we'll make it actually readable. Server visited DAC visited FFT, do that, and then we can basically just do the exact same thing here. We do this and do false down here, and for everything which is server count, then do visited DAC visited FFT, and let's put those here as well. So will also be this. What we do is if current is equal to DAC visited DAC is true. Same thing here for FFT visited FFT is true. And now down here we can do visited DAC and visited FFT 1. Otherwise 0, basically what we had before, but allows for this to be done. Yep, so because we've got that, we're properly returning the cache numbers, get connected, do this, and okay. Yeah. So I did have I was going to do the booleans outside originally, but then I would have to manage the state of that throughout. Because we're doing it only in here, once you turn back to the parent one, which called this, these are going to still be false. So you don't actually need to like go down to the bottom here and then change it. So that should be all good now. Gave 2, I think that was correct. It is. So now just need to hope that don't have any issues with this one. That is definitely wrong. Out of curiosity, I don't think I did a minus anywhere. So out of curiosity, did like overflow something? Make these all longs. Okay, so I've made these all longs. You're still this should be total. Try again maybe. Okay, well I'm happy that was the issue. I thought it would have thrown an error instead of just being happily going over, but let's see if that worked, and it did work. So there's day 11 of Abandoned Code 2025 complete. Make sure to like and subscribe.